Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 26, 2025, about 3 days ago. The big hook is a method that breaks a new exploitation cascade failure in long multi-turn tasks, delivering up to 152% improvement on Science World and up to 19.8% on ALF World. The paper is titled EPO, Entropy-regularized policy optimization for LLM agents reinforcement learning. And as we'll see later, the implications for model training are quite significant. In short, this paper introduces entropy control across trajectories with historical smoothing and adaptive weighting, guaranteeing decreasing entropy variance while staying compatible with common policy optimization. With that setup explained, Figure 1 shows the cascade failure across training. Entropy, meaning the randomness of action choices, spikes in the early steps for the baseline, which raises uncertainty without translating into reward. That instability then propagates to later steps, so entropy keeps oscillating and rewards plateau. With EPO, entropy stays bounded across steps and the reward climbs steadily. The contrast indicates that temporally aware entropy control converts exploration into consistent progress. So Figure 1 showed the dynamics. Table 1 reports head-to-head performance across Science World and ALF World. The key message is that adding EPO to policy optimization consistently raises success rates. In distribution means tasks similar to training, while out of distribution means novel variations. On Science World, the relative gain peaks at 152%. On ALF World, the best improvement reaches about 20%, and the results stay stable because entropy smoothing controls exploration. So while Table 1 summarized head-to-head gains, Figure 2 shows how those gains unfold over training. The top row tracks Science World, where EPO lifts rewards smoothly and pushes success toward near 1 while baselines stall. The bottom row covers ALF World, showing steadier climbs and reduced swings, which signals better stability and generalization. Confidence bands tighten with EPO because smoothing reigns in entropy oscillations, so exploration becomes consistent progress. Okay, Figure 4 presents model studies on Science World and makes one point: consistent entropy pressure wins. Left panel shows PPO plus EPO-based lifting rewards steadily, while the decay schedule flattens because exploration is throttled. Middle panel compares EPO to entropy-shaped advantage, where success climbs toward perfection with EPO but stalls for the alternative. Right panel plots early versus late entropy and reveals that cutting early exploration propagates uncertainty to later steps, which destabilizes learning. Alright, 2 takeaways stand out. First, long multi-turn, sparse reward training needs temporally aware entropy control, and the EPO recipe of trajectory entropy, historical smoothing, and adaptive weighting breaks the cascade failure. Second, this plugin works with standard policy optimization, lifting success and stability across benchmarks. That is it for this episode of the AI Research Roundup. I am Alex, thanks for listening.